Hi, so today we have a question from chapter 5, problem 5.30. So it says some sliding rocks approaching the base of a hill with a speed of 12 meters per second. The hill rises at 36 degrees above the horizontal and has a coefficient of kinetic and static friction of 0.45 and 0.65 respectively with these rocks. So there's two parts of this question. Part A and Part B. Part A is find the acceleration of these rocks as they slide up the hill. So it's going up the hill. So to solve this problem, we need to first read the problem as we did before. And now we need to do the free body diagram. So doing the free body diagram helps us understand the problem more. So we have 36 degrees angle, and here's the rock. So make the rock bigger. We're going to have a weight, which equals to mg. And we're going to have force of friction, which is the opposite of the velocity. It's going up, and the acceleration is going to be going down. And we're going to have a normal force, F of n, which is perpendicular to the x-axis. And the weight has two components because it's a magnitude, so it has two components, which is the mg sine theta, right here, this is theta, and mg cosine theta. Okay, so now we've seen the problem, we've drawn this free body diagram. It's time to apply it to the functions we have, to the formulas. So we know that the sum of all forces in the x direction equals to ma of x. The sum of all forces in the y direction equals to ma of y. But this equals to 0 because there's nothing happening in the y direction. It's only the x direction where it's on the incline. Okay, so the sum of all forces, we have two types of forces right now in the x direction, which is the force of friction and the and one of the components, the x component of the weight. So adding those together, force of friction plus mg sine theta equals m of a of x. Force of friction is going to be the normal force times mu. And that's going to be, the normal force is going to be mg. So it's going to be mu mg cosine theta plus mg sine theta equals ma. So we can cancel the m's on both sides. We have a common factor of g. So it's going to be g times mu of k cosine theta plus sine theta equals to a of x. So now we just plug in the numbers. 9.8 times 0.45 cosine 36 degrees plus sine of 36 degrees. That's going to give us a. So a equals, if we calculate that, it's going to be 9.3. That's for the first part. So we found that. So going to the second part, which is once the rock reaches its highest point, will it stay up or slide down? So if you think about it, it's going to slide down because there's not enough force of friction to stop the ball from sliding down in the opposite direction. So going back to the free body diagram, in the second case of B, we know that the force of friction is going to be, the velocity is going to go down, which means the force of friction is going to go to the other side. So the force of friction is going to be going to the other side. It's going to be going up. F of F. So now, applying what we had before, right back here. So the sum of all forces is going to be different because we have a force of friction going up, which is negative, and the weight in the x component is going to be positive, and just add up the forces and we'll get the acceleration again. So it's going to be the mg sine theta, which is the x component of the weight, minus force of friction, which was mu of k mg cosine theta, and that all equals to ma of x. Cancel the m's as we did before, take a common factor of g. Sine theta minus mu of k of cosine theta is going to be equal to A. Plug in the numbers again, and we'll get so we get that this is going to be 2.19 meters per second squared. So now the first acceleration going up, A up, is going to be equal to 9.3 meters per second squared, and A down is going to be equal to 2.19 meters per second squared. So that's how you solve the problem. Thank you.